Hello all, welcome to Scottish Summit 2021. My name is Sandeep Pawar. First of all, I would like to thank the wonderful sponsors, the organizers, and the volunteers for making this event possible. This is one of the biggest events that I have been a part of, so I'm extremely excited. And it's really wonderful how well the organizers and the volunteers have planned everything in this event. So thank you very much for that, and thank you for attending my session. A little bit about myself. I work at Cree Lighting in US. We are a LED lighting manufacturer company, and I work there as a data analytics engineer. So primarily working on data science, business analytics on the operation side of things. I'm very active on social media, so do follow me on Twitter, LinkedIn, and on YouTube as well. I also do some technical blogging on my website, powerbi.com. So take a look at it and do follow me. The topic for my presentation today is enterprise risk modeling and analysis with Power BI. The agenda is very simple. First look at why we need to study risk modeling. Second, what is risk? And third, how can we quantify that risk and what can we do to mitigate those risks? Let's first look at a typical dashboard that is created in Power BI. Power BI, Tableau, doesn't matter, but a typical dashboard that we generally, that the business users typically use. So this is all the usual stuff. It's the nice charts, KPIs, tables, slicers that the business users use. And there is always some sort of a story that we're trying to tell with these dashboards. And what is that story? Well, what were the sales, for example? What did the distribution of those sales look like? Which location sold the most units? And then, what was the profit? What was the trend like? Well did we do last quarter compared to this quarter? So on and so forth. And if you get my drift here with the words that I've highlighted here, all of these are in past tense because the stories that we tell in this case are about something that has happened in the past. And that is important to keep in mind because all these historical data or the stories and the dashboards that we create, these come with a big giant asterisk that past performance is not indicative of future results. And why is that? Because life happens, right? Look at the current pandemic that we are in. No one could have predicted or prepared for what could have happened a year ago. We didn't know. Brexit, for example, or the bond interest rates, or consumer preferences have changed. Things have moved online. More competitors are there, or maybe fewer competitors are there. So there's always something that's going on that is internal within your company, or it could be external outside your company that affects your business. And wherever there are these changes and uncertainty, there is risk. And these risk, as I said, could be internal, external, it could be anywhere. But usually, when we say risk, there is some negative connotation associated with it. That okay, risk is bad. Well, in certain cases, risk is bad depending on the scenario that you are in. But risk also means opportunity. And if we can manage and understand these uncertainties, we can manage and understand risk. And that means we can create more opportunities for our businesses to grow. Peter Drucker, who was a business management guru, he used to say that if you can't measure something, you can't manage it. And that's really the motivation behind this presentation. That can we identify and measure those risks so that we can manage them or learn to manage them well. And companies and the businesses that do that, they tend to be more successful over a long period of time. So let's look at some demos and how we can do this in Power BI. So let me launch this in Power BI. And if the data set that we are going to work with, let me show you that a little bit here. The data set, it's a typical business data set. We have a product line, some product, a customer segment, product category, product subcategory, and then some sales associated with it, and the date, all the stuff that we as business developers are very used to looking at. The goal here is based on this data, can we identify the products that are risky? Where are the uncertainties? So let's start looking at that and do some exploratory data analysis. So what I'm going to do is product subcategory. I'm going to launch it over here, and then I'm going to take the sales amount and then drop it here. If I go and just look at up here at the top, and then let's see data bars and then plot some data bars here. You'll see that we have these products, and the top of the product, these are office chairs and tables. So, and then at the bottom are these products. So what is the story we can tell from this? Somebody looking at this is the products here, maybe this telecommunication and copiers and fax. We sold more of these, so these are less risky products compared to these at the bottom. We did not sell as many of those. Um, so I've summed all of my sales here. Another popular way or usual way of looking at the products or these quantities or matrix is averaging them. So let's average here, and I'm gonna do the same thing just so that it's easier to see. I'm gonna drop some data bars. Remember, I said telecommunication. Yeah, it's third most sold product, but on an average, it is did not sell as many. So does that mean it is more risky compared to chairs and mats or compared to copiers and fax? Copiers and fax, we did not sell as many compared to the top three, four products, but on an average, we sold a lot more. So does that mean copiers and fax is less risky than these products? And this is where we have to define what risk means. So let me go back to my presentation here. So if I go to my presentation, as we said here, risk or uncertainty means variation. So if we look at this, let's say a picture over here, if I hit a target every single time and get the same number, does that mean it is risky? No, because there is no uncertainty or variation associated with it. Whereas if we throw a dart on this board and each single time we get a different number, we have some sort of a variation associated with it. And that means there is risk. We cannot hit the same target every single time. So there is some probability of that happening. And wherever there is a probability, there is statistic. So if we consider these two curves over here, the blue curve and the orange curve, they have the same mean. So on an average, we will hit number 1000 on an average every single time with these two events. But if we look at the spread, the orange one is spread more than the blue one. And how we know that is based on the standard deviation. So if we calculate the standard deviation of it, for the blue curve, the standard deviation is low compared to the orange one because it has a lot more spread or uncertainty or variation associated with it. So uncertainty or risk can be represented statistically, and one of the ways we can do that is by considering standard deviation and assigning probabilities and statistical distributions with it. So which is what we are going to do with our example over here. So I am going to take the sales again. I'm going to drop it right here, and then I'm going to calculate the standard deviation. And then I am going to do data bars. And if I do that, now you will see that telecommunication, although the sales on average is a lot lower, but the standard deviation is also lower, meaning the uncertainty when selling that product is also lower. Copiers and fax, on the other hand, the average is high, but there is high uncertainty associated with that product. But standard deviation is very hard to communicate to business users. So there's another measure that you can use that's called coefficient of variation. And If I click here, I'll show you what the formula for coefficient of variation is. It's just a division of standard deviation and average. So we are normalizing our standard deviation by average. So it is easier to compare different things on the same scale. So now if I go here and then plot the data bars, you will see that coefficient of variation for telecommunication is actually low. So even though we did not sell on an average a lot of these, but there is very low uncertainty when selling telecommunication products or binders and accessories, very high uncertainty around that particular product. So standard deviation or using coefficient of variation, these statistical matrix we can use to identify what the uncertainties are. Another way to communicate risk associated with this is what I call demand segmentation. And the way you can do that, if I create a scatter plot, take sales, I'm going to take the sales, go to plot it on the y-axis, take CV, plot it on the x-axis, and then take my subcategory, drop it in the details. And now you will see this risk profile that I've generated. I'm also going to do a couple of things. I'm going to take the order date, put it in the y-axis, and right over here. And then for the hierarchy, I'm going to choose year as my hierarchy. So I do that. And then if you look at this and if we play this now, you'll see how the risk has changed. So what we are saying here is the products that are on lower on the x-axis, these have lower uncertainty, lower risk. So these products over here have lower risk, whereas the products over here on the x-axis, they have higher risk. So now we are able to compare. If I take the sales again, put it on, and then calculate their standard deviation. Now we can tell a different story. Here, if I play again, you can see how the size of those bubbles change. So it tells us, for example, if I click on this, how did the risk change? So from 2010, we started with very high risk, then it lowered a little bit, and then went up and then lowered again. And all this while by keeping about the same standard deviation, but we in 2013 we ended up with higher sales. If I take the telecommunication product, the risk profile has stayed the same. So we are within this 1 and 1.5. So risk profile has stayed the same, uncertainty has remained the same, but we have increased in sales from going from 2010 to 2013. So this is a nice way for us to look at how the risks have changed, and at the same time understand how different products can be categorized. If you go here and then click on or actually let me get rid of the risk axis probably, and let's go here. Yeah, you can click on automatically find clusters here, automatically find clusters, and then you can find clusters within this group. And if I drop it in the legend, now you can see that these orange products have lower risk, higher sales, whereas these dark blue have low sales but high risk. So you can create these risk profiles for your customers. You can create it for your products, for your markets and segments, and all of the different matrix or the products that you have. And it gives you a different dimension of looking and analyzing your data, which is very important, because what happens when you are only looking at averages and sums, it aggregates everything. It aggregates all these uncertainties, and it doesn't give you or your business users the full picture as to what exactly is happening. This CV that I'm using, the coefficient of variation, it could be a coefficient of variation of anything. It could be your demand, it could be your production volume, it could be your customer preferences or anything. You have to define what is it changing and then create or identify some sort of a risk or measure of uncertainty around that, and then analyze how things change with respect to that risk. So this is just as one example. Now, usually Depending on the industry, usually a coefficient of variation that's less than, let's say, 0.25 or zero point 0.3 is considered low variation. Anything between 0.25 to 1 is, or 0.75 is medium, and anything above 1 definitely is high variation and high risk. In this case, because this is a synthetic data set, but the numbers are very high. But in your case, it's probably going to be between zero point 0.5 to 1. So you can create these different demand segmentation plots and then identify where the uncertainties are, and you can play with it. So now your boss is very happy that you identified a product that is, so this telecommunication, for example, right? So we looked at the order date. So if I take the order date and then on the y-axis here, and then, yeah, look at the year, and then we did look at it earlier. And when we looked at it earlier, we saw how it improved. So it improved in sales for the same risk profile, so which is good. So your boss says, okay, go ahead and let's do some market research and find out if we can launch a new product into this telephone and telecommunication product subcategory because it looks very promising because it seems that we are doing something right. So you go and do some market research. So you'll go and do some market research. You look at the last year's data. This is just for telecommunication. We're looking at only telecommunication data. And you do some market research and you say, okay, last year in 2013, we sold about 400,000 units and our profit was $110,000. Usually, when you are doing something like this in Power BI, you can create like a what if scenario analysis. And you create a what if scenario analysis, and then you can just multiply and then see, okay, well, last year we did 110,000. Maybe growth is 25% more, or it is flat, or it is 60% more. And with what if scenario parameter, you can multiply your quantity or measure and then create something. So in this case, I'm saying it will be 47% more than last year, so $160,000. So, but the problem with the what if scenario is that it is extreme variation because 40% and 60%, there is an equal probability of that occurring. It's the exact same probability. But is that the case? Not really, right? I mean, if you say 10% growth rate, is that possible? I think so. That is more likely than, let's say, 80% growth. So there is some probability associated with it, which is not captured if you take a what if scenario kind of, if you do what if scenario kind of analysis using uniform distribution. A more realistic analysis that we can do is using Monte Carlo simulation. And what a Monte Carlo simulation here is, we instead of looking at just one scenario, we look at lots and lots and lots of different scenarios. And an example of that is you do some market research with your colleagues, and let me go here, and then you present this to your boss. You say that, okay, we did some market research, and based on some historical data, we think that on an average, maybe we'll sell about 3,000 units. And because we are in a pandemic, if the pandemic prolongs, then the sales volume will be 1,000. It will drop from 3,000 to 1,000. And if the vaccination drive that's going around around the world, if it is successful, then we'll see higher demand for our products, and then maybe from 3,000 it will shoot up to 8,000 units. The price could also vary between 65 to 105. We did some market analysis, some customer analysis, and we think that our price range should be between 65 to 105 based on our previous legacy products as well as what's out there in the market. And there's a 70% chance that a competitor might launch a new product, um, in 30% chance, obviously, that they will not launch a new product. That's just based on your market analysis. Now, if a new competitor or a competitor launches a product, then that means that your volume will be affected, right? So in this case, the product manager, maybe you spoke with them, and the product manager thinks that if a competitor launches a new product in the same space at the same time as we do, then our volume will be affected by about 50 to 70%. And the cost will vary from 30 to 60% of the price based on the supplier that we choose. Right now, if you're in the manufacturing industry, you know that a lot of the supply chain is really strapped because of the pandemic. So depending on if we have to go overseas or if we can make it within the country, the cost could vary based on the supplier from 30 to 60%. So that's a pretty wide range. So given all these factors, based on the analysis that you have done, now you want to understand what is the probability that we will hit $110,000, at least $110,000 profit when we launch this new product. Where does 110,000 come from? That's just based on the historical data. Remember, I showed you the Power BI slide where we saw that last year the profit was $110,000. So the boss says, okay, we want to be conservative and we want to be at least have, because it will be a new product, at least have that much profit um, when we launch the product, and maybe it will pick up the following year. But we want to start on that's the baseline. So how can you calculate the risk associated with it? How do we quantify the risk? Should we launch the product? And if we do launch the product, what can we do to mitigate those risks? And this is where Monte Carlo simulation comes in. Now what we're going to do is assume all these scenarios are these dice that you see on the screen, and we are going to roll these dice thousands of times. And each die here represent the scenario that's going to happen. So this over here, for example, this over here is your volume risk, this is your competitor risk, this is your cost risk, and so on and so forth. And in this case, the die here has a uniform distribution associated with it. You'll either get 1 or 6 or 5 or 3 or 2. Each of them have equal probability of happening. But what we are going to do is we are going to use and associate not just the standard deviation, but a distribution to it. And what that means is what we'll do is if you look at this curve over here, the probability of 10 is low. The probability of 15 happening right up at the top here is extremely high because that's the mean. That's the top of my probability distribution. Whereas 35, if it's on the tail end, right? It's on the tail end, so there is less than 5% chance, or maybe 2.5 if you see over here. So less than a 2.5% chance that of 35 happening, and which is what we are going to do in our case. So for a volume, if you remember, the numbers were 1,000, 3,000, and 8,000. So 8,000 will be somewhere around here because there is a very low chance of 8,000 happening. 3,000 would be the base case. So this is where the 3,000 would be. And 1,000 would be somewhere around here. So it's definitely an asymmetric distribution, not your typical normal curve that we see. So how are we going to calculate the profit? Well, the formula is very simple. We take volume, whether the competitor has launched the product or not. And if he has launched the product, then we will derate that volume by a certain percentage. And then we'll also take sales, deduct the cost from it, and then we'll calculate the profit based on that. Now, if we don't take any uncertainty into account, like we do it the traditional way, right? We don't take any uncertainty into account. Then we'll just take the middle path and we'll say, okay, 3,000 units, maybe there is a 50% chance, so we'll multiply that by zero point 0.5 because maybe the competitor will launch, right? And then we take 98 and 39.2, which are our middle of the way um, uh, uh, estimates for those quantities. And what do we get? 88 200. And 88 200 is our new profit. This is without considering any uncertainty. If we go to if you go to your manager now and then say, okay, I calculated it and the profit will be $88,000. Do you think he will say that, yeah, go ahead and launch the product or start working on the product? I don't think so. Because remember, the target was $110,000. If we use our middle of the way estimates, then the profit would be $88,000. So he will shut down the program and he'll say, okay, we're not launching this new product. But what if we assign probabilities to each of these scenarios happening? So what we'll do is for volume, we'll assign one probability of happening, some statistical probability distribution, and to each of these. So for volume, it will be beta PERT distribution. Don't worry about what that means, but I'll explain that in a bit. But competitor is this, discrete, risk is normal, then a beta PERT and a truncated normal distribution. There are only two things that you need to know about this. There is a discrete distribution and a continuous distribution. Discrete distribution meaning it is like either it is something or it is not. So maybe, like a choice. Yeah, you can think about it as a choice. So like 20% chance of choice one or event one, another 25% chance of event two, and then a 50% chance because it always has to equal to one, 100% probability. So that's what discrete distribution means. It's like either this or that or that. Continuous distribution, on the other hand, means it's a continuous number. So like number of units or profit or sales or something that, or percentage or bond rate and things like that. So it is a continuous number that you can represent. Second thing that you want to know about distributions is it is a either symmetric distribution or not symmetric distribution for a continuous distribution. If it is a symmetric distribution, that means that it is equal probability of happening on both sides of things. Asymmetric distribution, which is this distribution and this distribution, these two distributions, those are not symmetric, right? If we take draw a vertical line right through the peak of that curve, the area on the right side and the left side are not equal. So it's not a symmetric risk in this case. So that's what we need to identify. Now, how do you create or assign these distributions in Power BI? There is no native formula, so you can create normal distribution in Power BI using the norm, the DAX. But I already have written a blog about this, so DAX formulae for creating statistical distributions in Power BI. And you can just go and copy the formula from here and then use it. I mean, it's as simple as that. It's nothing dramatic about it, nothing difficult about it. So you can use it. And at the end of it, you'll also have included a chart on how you can identify which distribution that you should be using. The most common ones are the beta PERT distribution, normal distribution, log normal distribution, and the triangular distribution. Those are the most common ones, and as long as you know if the risk is symmetric, that's the number one thing you would need to know. And two, if it is a discrete distribution or continuous distribution. And then you should be able to pick which distribution. It's a big topic. If you need any help, or I can definitely provide you more resources on that. So for now, we'll stick with that. And let's go to Power BI and let's see how we can create this Monte Carlo simulation in Power BI. So what I'm going to do is go to modeling up at the top. So I'm going to go to modeling here and I'm going to click on new table. So I'll go to new table and we want to create 1000 scenarios of this. So let me call this as a sim table, yeah, sim table, and then we're going to generate series and I'll I'll show you what I did here. Just give me 1 second while this creates the table. Okay, so what I did was I created a table and I said generate a column that has numbers from 1 to 1000 in the increment of 1. If I go here and then look at this sim table that I just generated. So this sim table that I generated, it has 1 to 1000 values in it. And these represent the different scenarios that we are going to do. So to add our volume scenario in here, all I have to do is I'm going to copy the formula from my website and I'm going to generate a new if I go to table tools, new column, I go to new column and then I'm just going to copy the formula from my website for per distribution. And I say, okay, the numbers are going to be 1000, 3000, and 8000 because I want this to be asymmetric. I generate that. And then you keep going. I'll just show one more. So to create the competition, what we are going to do is I'll create another distribution. Let's go here, new column. By the way, you can generate the same thing in Power Query using M. But the problem with Power Query is that these formulas are very complicated to do in Power Query. I was able to do them in DAX. That's why I'm using DAX. So I've created a distribution, discrete distribution. What I'm going to do is I use a rand function, which will generate a random number. If that random number is less than zero point 0.3, then the competitor hasn't launched the product or entered the market. If it is more than 3, then yeah, it has he has entered the market. That's how we generate this event happening. This is called a discrete event simulation. So we do that, and then we keep doing that for all the different factors that we have. I've already created one. We don't have a lot of time here, but I'll just show you what I did. So if I go here and then go to so I did that the exact same thing. So I created the competition, volume, risk, price, cost, and then profit is just based on the formula that I showed earlier. We're just taking volume times whatever is the price minus the cost, and I generate the profit based on that. So I calculate the profit, and if I go to the second example here, yeah, and then when I generate the profit from that, I can aggregate that profit now and calculate what is the average. And the average here in this case comes out to be $141,000. So let me pause here for a moment and just put it in plain English words what we just did. So what we did was we threw the dice. Remember the dice example that I gave you earlier? We threw the dice 1000 times, with each scenario happening. And all these scenarios are independent of each other. And we created this in an alternate world, in a virtual world, 1000 times. And now we are going to aggregate that and then see that what will happen on an average. What is it that likely going to happen, because we are interested in the probabilities, right? What is the probability of something happening? And that's what we did. And we found out that when all of these things happen, on an average, the profit will be $141,000. Now recall what we did earlier. If we don't take any uncertainty into account, the profit would have been $88,000, and the boss would have said, "Don't launch the product." Now, if we take all the uncertainties, all the risks into account, and risks represent opportunities, the profit now we are saying on an average would be $141,000. These are based on the assumptions, the market research that we have done. And what is the probability or the risk associated with that? Our risk here, we are defining it as the meeting that $110,000 target. What's the risk with that? About 42%, because 42% of the times, with all these scenarios that we considered, 42% of the times we actually did not meet the $110,000 target. So now you can go to your boss, and if he asks you, okay, you've done the market research, what is the probability of success here? And success here is in terms of meeting that target, or what is the risk? The success probability is the risk here is 42%, and the probability of success is 1 minus that 42%, which would be what, 50 or 48%? Yeah, 48% is our, or 52, 58% of is our probability of success. Now, is that high? Is that low? That will depend on your business, that will depend on your risk tolerance, that will depend on a lot of other things that you have in the business. And that is something your management will have to decide if it is worth taking the risk or not. Um, so yeah, so that's how we can calculate risk and estimate risk. Another thing that we can do, this is a completed example, is because these risks are we are creating the formula, we can turn that into a regression problem and use the key influencer. And now what this tells us is that our assumptions regarding volume is number one, and maybe price is number two. So this is how you can mitigate your risks. Now you have identified the factors that will affect your event of launching the product. So what this is telling us is maybe the price assumptions that you have made, either go look at it, maybe do more market research, or when you do consider launching the product, it's probably your market is very sensitive to price. So you have to, when you are doing your project management, you're launching the product, be very sensitive about the price if you want to succeed based on all the scenarios that we have created. So this gives you a lot more information and scenarios that you can play with and understand about your business. And as I said, your competitors are also going to have same uncertainties and same risks, but now you're able to quantify those uncertainties and risk and manage them very well proactively before you can do anything. Now, could this go wrong? Absolutely. If you're not careful, then with your assumptions, and if you're not methodical about your approaches, then it doesn't mean anything, right? Garbage in, garbage out. But I've done this, and companies, many companies, in fact, companies, big companies like Boeing, Caterpillar, even Microsoft, use these Monte Carlo simulations very often to test and understand the businesses, to understand the markets. In fact, if I in my presentation, if you go here, Thermo Fisher, which is a electronic, it's a big company, electronic microscope manufacturer. They use Monte Carlo simulation during COVID-19 disruption to see what their supply chain risks are. Now, the example that I showed you, it's a basic Monte Carlo simulation, but in Power BI, I've created a lot more complicated scenarios and a lot more complicated simulations to understand different things. You can do NPV analysis, you can do market segmentation, market analysis, you can do financial modeling and all that sort of stuff. In Power BI, you don't even need any advanced tools to be able to do that. So this is something that I had not, I have not seen many business analysts or data analytics professionals do. A different side of the data present to their business users. So I thought it would be a good topic to present. So hopefully you enjoyed this and learned something new. Do reach out to me if you have any questions. And thank you to Nikki for this event and to the organizers as well. And I think the video will be available in a couple of weeks or so. So keep an eye on Scottish Summit website and also keep an eye on my social media accounts and my blog if you want to be alerted about when this will be available. So thank you again for joining me. I really appreciate it.